I didn't record it. Oh, so let's do this. Madam Karen. Hello, Madam Karen.
Yes, sir.
Yeah, so now this one, unfortunately, the one I did, the recording was not done for this one, but I'm sure you remember. I actually mentioned that here, whether we look at the x as independent variable, and you remember what I mentioned that?
Yes, sir.
Yeah, so from this one, we said under forecasting, just a recap for those who missed it. Under forecasting, we look at the regression analysis where we say our x is independent variable, then y is a dependent variable, and this is the line of regression. You are able to see?
Yes, sir.
So this is the regression line. Okay, so this one is a line of regression. And of course, after this, we looked at the b is a slope, and then the alpha is the intercept. And then how you get the slope, we have this formula here, where we look at our summation of xy, which is this component, the summation of x multiplied by summation of y over n, and this one. If you have understood, this is the slope. Then getting down to the other one, this is the intercept. Okay. Intercept. All right, so now, okay, so now what happens is you have the mean of y and the mean of x. And this is the correlation coefficient formula. This one is called correlation coefficient formula, which measures the relationship between two variables. It's in order to see if we have a positive or negative relationship between the variables. Okay. So this is what goes on. And then of course, then we have to enter the data. When entering data, I mentioned that we're supposed to clear the memory, press on shift and modes, and all that. And even when entering data, these are the steps that we actually look at. All right. Of course, we actually also look at now a problem. So when entering data, we use a combination of x, y. It's similar to the DMT, the QM that you did. All right, then getting down to this problem, they're saying that from here, you assuming the P30 series cells that are representative of its next year's sales, use time series to find the forecast for 2022. So 2022 at this time, the year would be X. So the year would be equal to X. And then P30 cells will be equal to Y. Okay, then solving these ones using the table here, you do manual table, substituting the equation here. In this equation, we got our beta as 8.022 using this formula. and then substituting to get alpha using this formula, we got alpha negative 7.1466. And then the regression equation was this one. Then to get the sales revenue for year 7, which is 2022, you substitute the 7 in this kind of equation. Then it gives us 49.0136. All right, so this is how we got the sales for 2022. Then the other one, we are finding the equation now using the two parameters. The two parameters in this question, they are now telling us that using the O industry and the P30 series. So O industry and the P30 series. So O industry will be X. The P30 series will come from the O industry. So that's why we're saying O industry will be X. P30 series will be our Y. Then using the combination of from the table, we are simply getting down to the O industry and the P30 series, using this one, computing it manually. They are simply saying you square X at a time, Y is there, Y square and XY. Then you are getting down to the beta of 2.59173. Okay. Then this other one here, you're substituting to get alpha is negative 2.1544. Then we're trying to find the actual figure when it was sold 20.9 billion, when X was 20.9 billion. So when X is 20.9 billion, here we're substituting why X is 20.9 billion to find the other value. So the other value, which is finding Y, find Y when X is equal to 20.9. X is 20.9. Find Y. So our Y gave us the value here, which is 42.01. All right. Then the other question, the last one, that says find the which independent variable between time. There were two independent variables there, between time or industry. Which independent variable should we actually go for? Okay, the O industry or time. So what happens is that we have to look at the one which will give us our R square, the variation, which is a higher variation. Of course, when you have entered the data in a calculator, which we need to show you on how to enter the data when you have a calculator, it will be very easy for you to get the values, because the values are obtained from the calculator. So the R for when the time was independent, the R was actually the relationship is 0.98. As we square this one, it is 96.7. So the variation is 96.7 when time was independent. When time was X was independent, it was variation of 96.7. Now, when all industry was independent, our R is 97.6. So the conclusion is that the independent variable of that smart for industry sales revenue is the independent variable to use, because the correlation coefficient is higher, which is 0.98, and the coefficient of determination is also higher, which is 97.6. So this is what happened. So this is just a summary of the forecasting question. So you have an idea of what is going on in forecasting. So what is important is now to dig deeper so that you can come and understand this question thoroughly. All right. So we'll pause for 2 minutes for those who we're just doing a recap for those who actually who missed. In the next 2 minutes, after 2 minutes, we'll be looking at a different question altogether. So we just hold on for 2 or 3 minutes. We start the other question on a different topic. All right. So we can end here for now for this one. The recording will be shared. Take time to go through. All right.